Hello and welcome to the Key Stage 4 chemistry topic of cracking of alkenes. Before we get started, can you please make sure you have a pen, pencil, ruler and a highlighter or another coloured pen or pencil to self-assess it and show progress. Can you also make sure you're in a quiet room and away from any technology that may distract you and hinder your progress from this learning session. First things first, can you take 10 seconds to write down a learning objective to understand the need for cracking of crude oil? Okay, so have the retrieval practice on here, guys. Can you give yourselves 3 minutes to have a go at the 3 questions? So pause video for 3 minutes and have a go. Okay, time's up there, guys. The 3 minutes is up. Can you pick up another coloured pen or pencil, and we'll go through this now and show progress. So, question 1. What is the word equation for the complete combustion here, guys, of a fuel? So it's hydrocarbon plus oxygen, and that makes carbon dioxide and water. So complete combustion is when there is oxygen. Incomplete combustion is when there is a lack of oxygen, and that's when it can be dangerous and produce gases such as carbon monoxide. Question 2. What different gas is produced by the incomplete combustion of methane? So as I just mentioned, carbon monoxide is a poisonous gas. And then what does volatile mean? A key word there, volatile, is a measure of how readily a substance vaporizes, or in other words, how easily that substance turns from a liquid state into a gas state. So give yourself a mark out of 3 there, guys. Excellent if you got 3. 2, well done. 1, let's address those misconceptions. Okay, so this is what we're doing in the learning session today. So we're going to explain why cracking of large hydrocarbons is so useful, describe the process of cracking, one of the processes, and then the difference between an alkane and an alkene. So, got a short task for you guys. This is a key GCSE skill is looking at data on graphs and tables and picking out the key points. So what I want to do is, looking at the graph, can you fill in the missing words in the paragraph underneath? So please write down the paragraph underneath and fill in the missing words. I'll give you 4 minutes for that, guys. 4 minutes, go. Okay, time's up there, guys. So this graph just shows all the different fuels that are extracted at different temperatures by the process of fractional distillation of crude oil. So petrol, as shown here, is the short chain with bitumen, and fuel oil, the long chain hydrocarbons. So from this graph, from this data, and the key on the right hand side, we can understand that short chain hydrocarbons have a lower supply but a higher demand. So the short chains have a lower supply but a higher demand. Now if we compare this with the longer chain hydrocarbons of fuel oil and bitumen here, it's the other way around. So long hydrocarbons have a higher supply, so a lot more availability of it, but the demand is much less, guys, much less. So can you give yourself a mark out of 4 for that, guys? If you've got 4 out of 4, well done. 3, good. 2 or below, let's improve there. Okay, so what are the reasons for cracking? So you can pause the video just for a second, guys, just for 10 seconds to get these down. They are smaller hydrocarbons in high demand for fuels. And alkenes are used to produce polymers, plastics, and as starting materials for the production of many other chemicals as well. So for fuels and for making polymers for plastics and production of other chemicals using pharmaceuticals. Okay, so, but what is cracking, guys? What is it? So the long chain hydrocarbon is broken down using heat. That is the definition of it there. By using thermal decomposition. Thermal decomposition is breaking a substance down with heat. And that produces, so in the diagram here, you have a long hydrocarbon, you break it down with heat and a catalyst, more on that in the next couple slides, and it produces an alkane and a type of hydrocarbon called an alkene. So, there are 2 methods, guys. We're going to focus on the first one only today. That's catalytic cracking. Can you pause the video and get down this key information now, guys? The key difference between these two methods of cracking of hydrocarbons is that catalytic cracking involves a catalyst and thermal decomposition, whereas steam cracking does not involve a catalyst and is a higher temperature of 800 degrees Celsius there, guys. So we're going to focus on catalytic cracking there, guys. So can you do the same again? This is a short, brief methodology. Can you draw in the diagram and get in the surrounding information? I'll give you 5 minutes for that, guys. 5 minutes, pause the video here and get down the key information. Okay, guys, so hopefully you've got that key information down there about catalytic cracking. So I want you to have a go at these review questions now. The diagram shows an apparatus that can be used to carry out the cracking reactions in a laboratory setting. So I want you to pause the video for 4 minutes and answer the 3 questions, A, B, C, and give yourself 4 minutes for that, guys. So 4 minutes, go. So your 4 minutes up there, guys. Can you pick up another coloured pen or pencil, and we'll go for this and give yourselves a mark out of 3. So question A, why is aluminium oxide or broken porcelain used? So it's used as a catalyst, and a catalyst always speeds up the rate of reaction, gives it an energy boost in that term. So it speeds up the rate of reaction because it's a catalyst. Question B, the cracking of decane, which is C10H22, is just here. So the breaking down of that can be represented by an equation below. So this one here. You just need to complete the equation. So you're given C10H22, the hydrocarbon or decane. You're given the alkene, C2H4, but the alkane is what's missing. So hopefully got this, guys. It's C8H18. You just had to work out the difference between them. So there's 2, so there's 10 there, 2's already there, so 8, so C8, and then H22, take away the 4 from the hydrogen, it's just 18 there. And then for question C, would you expect C2H4 molecules to collect at position A or B on the diagram? So here or there, and give a reason why. So it will collect at B because it is a gas and it has small molecules. Remember, it's a gas, not a liquid. So it's a gas, as it's stated by here, the G stands for gas, and that is its state. So give yourself a mark out of 3 for that, guys. Excellent if you got 3. 2, well done. 1, let's add in the corrections there. Okay, guys, so can you pause the video again and have a go at these 2 questions here? So same idea, I'll give you 4 minutes. Can you pause the video for 4 minutes and answer the 2 questions? Go. Now, your 5 minutes are up there, guys. I'm going to go through this in green pen or another coloured pen and pencil once again. So, this question just asks, most of the hydrocarbons are alkanes, of course. Large alkane molecules can be cracked to produce more useful products, as we've just gone through that. So, give 2 conditions used to crack large alkane molecules, any 2, guys. So, 1 would be the high temperature of either 800 degrees Celsius or 550 degrees Celsius. High temperature would be fine. And the second one, as already mentioned in catalytic cracking, would be the presence of a catalyst such as aluminium oxide. Okay, guys, give yourself a mark out of 2 for that. And then for question B, cracking reactions involve thermal decomposition. What is meant by thermal decomposition? Two key points for this, guys. So breaking down of a substance, any substance at all, using heat. So breaking down of a substance using heat, guys. So 2 marks for that as well. And then can you give yourselves a mark out of 4 overall? Excellent if you got 4. 3, well done. 2 and below, let's improve on that there, guys. Okay, so quick recap of alkanes. So alkanes are a family of hydrocarbons with only single covalent bonds. So covalent bonds, because covalent bonds are between non-metals only, so each bond between them is only a single bond. They are known as saturated hydrocarbons because they are all single bonds only. Examples are ethane, propane, and butane, and they all have the general formula, alkanes, all have the general formula of CnH2n plus 2. So for example, if I have 2 instead of the n, so n replaces number, so C2, I have times 2 plus the 2 of it, so C2 times 2, it's C4 plus the 2, so that's C2H6. Alkenes, though, on the other hand, are a family of hydrocarbons with at least one double bond, and they are unsaturated, and they have the general formula, with examples, ethene and propene and butene there, of CnH2n. So there's no plus 2 here, because of the double bond between the carbons, and that makes it unsaturated. So just going to show you a short example of cracking decane, which is a 10 carbon long hydrocarbon. So we're going to add a bit of heat and catalyst, 550 degrees Celsius for this, and the catalyst. Heat it up, heating up, and then it is broken down into an alkane and an alkene. So the alkane, which is on the bottom here, is octane because it now has 8 carbons. It's lost to 2, and they've been lost to the ethene, which is 2, but that's got a double carbon bond. So that is now unsaturated, whereas the octane is still saturated because it's got single bonds between them. So breaking the longer hydrocarbon down into an alkane and an alkene with a double bond. So in your books, guys, or on your pieces of paper that you have or typed up, can you pause the video for 8 minutes, and have a go at these questions here, guys? Can you write them out fully and fill in the missing blanks? So what are the missing blanks just there? So 8 minutes, go. Okay, you're 8 minutes up there, guys. We're going to go through this. So can you pick up another coloured pen or pencil, and we'll give ourselves a mark out of 6. So the answer is going to come up now. We just add these in. So the first one, C7H16, C8H16, C15H32, C5H12, C5H10, and C9H20. So those are the answers there, guys. Can you add those in? Give yourself a mark out of 6. And then we're going to move on to the final task. This is now going to be the final task. Can you pause the video for 8 minutes again, write down the paragraphs in full, and add in the missing blanks again, guys, the missing words. So pause the video for 8 minutes, again, have a go, and then we'll go through it in 8 minutes time. Okay, your 8 minutes are up there, guys. Can you put down your pen and pick up a green pen or another coloured pen and pencil, and we'll go through this and self-assess it. So the answer is going to come up on the next slide, guys. We add them in or give them a tick as we're going through. So the large alkane molecules are broken down to smaller molecules, one of which is a smaller alkene. Remember, that's got double bonds and is unsaturated. The other is an alkane that's saturated and has only single bonds. This reaction is called cracking. The small molecules are more useful than the larger molecules. To do this, we either need a high temperature and a catalyst, aluminium oxide, and this is called catalytic cracking, or we heat the alkane to a very high temperature in the presence of steam, but without using a catalyst, and this is called steam cracking, guys. So, can you give yourself a mark, guys, from there? Excellent if you got 13 and above, guys. 10 to 12, well done. 7 to 9, well done. And then below 6 and below, let's add in the corrections there, guys. So that concludes the video and learning session on understanding the need for cracking of crude oil, so the cracking of alkenes, guys. That is Key Stage 4 chemistry topic. Thank you for listening. Have a great day and take care.